So the first one, this is when you see the negatives, it's even and odd. Is secant even or odd? Let's start with that. Even, good job. Okay. All the odd ones go negative. The even ones turn positive. So this will just be secant of x. That is it. The even ones, if you see a negative, that's even or odd. Even ones turn positive, odd ones turn negative. This is memorization. All right. Now, whenever you see the squareds, that is Pythagorean. Be really honest with you, I only memorized the first one. These say X. I have it written on here with theta. Don't get caught up on the letter of the alphabet, okay? But I memorized this first one. Sine squared plus cosine squared equals 1. The way you can get the others, let me see what order I did this in, is if you go through and you divide each of those terms by sine squared, what would you get? Well, what is sine squared divided by sine squared? What's anything divided by itself? It's good, okay. Cosine squared divided by sine squared. Cosine over sine is cotangent. The way I remember that is the co one is the one on the top, so it's cotangent. And then 1 over sine squared, well, your reciprocal of sine is cosecant. There's just a squared, okay? Now, if you go through and divide all of those by cosine squared, sine over cosine is tangent, just squared. Cosine squared over cosine squared, 1. And then 1 over cosine squared, your reciprocal of cosine is secant squared. Or you can flat out memorize all 3 of those balls in your course. Teaching these is very difficult because you can't teach memorization. All I can do is present this. I'm not really teaching it. I am presenting it, letting you know kind of how it works in my mind. But at the end of the day, you have to put it into your mind somehow. Do you get what I'm saying? Like, I can't teach memorization. I can present it. It's up to you to memorize, all right? But I keep these on a sticky note off to the side. Let's look at this one. 1 plus tangent squared is going to give you what? Yeah, 1 plus tangent squared is secant squared. It's just right there in the identity. So secant squared. All there is to that. And I'm just going to keep my little sticky note off to the side in case we need it again. Here, when you see something like this, my go-to is turn everything into sines and cosines with the idea that something should cancel out. Now that already is sine, so when that's the case, I put it over 1. If it already is a sine or cosine, I'd put it over 1. I'm going to draw a great big fraction bar. What can I replace tangent with? It's like a series of replacements. Yeah, good. Sine over cosine. It sounds like that went well without me here. You guys had to learn this by video, and I felt bad about that, but it sounds like you guys handled it. So. Now, when you divide by a fraction, you multiply by, so good, perfect. So I'm going to have sine x over 1, just keep that the same, times, and then I'm going to just flip this over, so it'll be cosine over sine. And again, the goal with turning everything into sines and cosines is that something should cancel out. And it does. What cancels out? Yeah, sine, you get cosine over 1, which is just cosine. So the goal is to replace things and look for something to cancel out. They're like little puzzles. All right. Here, let's turn everything into sines and cosines. What can you replace secant with that would have a sine or a cosine in it? Yeah. 1 over cosine. It's the reciprocal of cosine. Good. Minus, and what can you replace tangent with? Sine over cosine. Now, you might not be like, oh, that looks any better, but they have a common denominator. So we're just going to push them together. So it's going to be 1 minus sine x over cosine x. After that, there's really nothing you can do to that. And you might be like, how did we make it better? And that's a valid question. But we now have 1 fraction instead of 2 separate fractions. So that's why we consider it more simplified. If you are taking a quiz or test and you're not sure how far you have to go, am I done, Ms. Cole, is a valid question that I will answer for you. You can always call me over and be like, am I finished? And I'll be like, yes or no, you have more steps. Okay, so just let me know. All right, let's replace everything with sines and cosines. This already is cosine, so I'm just going to put it over 1. I'm going to leave it alone, but I'm just going to put it over 1. Times, little dot there. What can we replace cosecant with? 1 over sine. There we go. I knew what you meant, but yeah, 1 over sine. Great big fraction bar. And what can we replace cotangent? Yeah, cosine over sine. And then we're going to stop and take a step back and look at what we have there. In the numerator, you have cosine over sine. And then down here, you have cosine over sine. So the whole thing is 1, which is great. Whole thing canceled out. All right, for this one, see that little squared there? That means that you have a twin. It's 1 minus sine of x, 1 minus sine of x. And flip you, and we're going to just multiply it all together. So 1 times 1, 1. Bless you. The outsides give you minus 1 sine x. The insides give you minus 1 sine x. So together, be minus 2 sine x. You minus 1 of something and minus another one of something, you minus 2 of them. And then the last, negative times negative, positive, and sine times sine is sine squared. Nothing else we can really do with that. If you're like, hey, there's a sine squared, let's look at our Pythagorean identities, but we don't have a cosine squared in there, do we? If you had 1 minus sine squared, but it's not, it's plus sine squared. So there's really nothing else you can do with that. And you might be like, how did we make that better? And that is a valid question. And I don't actually really have a good answer for that one. So it's because this is part of the standards and they said so. All right. This is a co-function. When you see 90 minus, it's a co-function. You simply add or remove a co. This is why I harp on about saying them correctly. Okay. How would you say this? Cosine. Just remove the co and it's sine. Say it correctly, think it correctly, you'll get the correct answers. That's why I harp on about it. Yeah. All right. Let's replace everything with sines and cosines. This already is sine, so I'm just going to put it over 1. If I'm not changing it, I just throw a 1 in there because oftentimes things cancel. Little dot, and then what can we replace cosecant with? 1. Yeah, 1 over sine. And then minus cosine squared. I'm not going to change that because hopefully you'll see what's going to happen in a second. What's going on with the first part? Yeah, they cancel. That's just 1. So 1 minus cosine squared. And when you see the squareds, that's the Pythagorean one. So let me pull this back out. Looking at this first one. If you have 1 minus cosine squared, can you imagine subtracting this cosine squared to the other side? So 1 minus cosine squared would equal sine squared. I'm pretty pleased with how this is going. I was actually kind of nervous about it since I missed last time. You guys are handling it. All right, we're going to multiply all this together. Cosecant times cosecant would be cosecant squared. Now, when you do the outsides and insides for this one, what's going to happen? Yeah, they cancel, so that's great. And then 1 times negative 1 is negative 1. Now, if you see a squared, again, that's the Pythagorean one. So let me pull this out. Are we looking at the first one, second one, or third one here? Yeah, the second one. If you have cosecant squared minus 1, that's going to equal cotangent squared. Good job. All right, we're going to replace everything with sines and cosines. So that first part just is sine. I'll put it over 1 for good measure. I'm not actually sure what happens with this one. We'll see. Believe it or not, I don't have like this all memorized. I kind of just feel my way through it. Like I'm just going to replace everything with sines and cosines and see what I get. What are we going to replace cotangent with? Yes, cosine over sine. Good job. Little dot. And I'm going to leave cosine alone, but we'll just put it over 1. Okay, I'm remembering how this turns out now. Do you remember the one before where we had 2 different fractions and it already had a common denominator? And we didn't get lucky on this one. We have to get to a common denominator. So what is your common denominator between these two? Well, 1 sine x, okay? So we have to multiply this one by sine of x in order to make them be the same. I made that with a different color, but it kind of didn't show up real good. All right, but let's see what we end up with. Sine times sine, sine squared, plus, now what do you have over here in the numerator? Cosine Squared, good job. Big old fraction bar, common denominator was sine. Good job, you hung in there. This is probably the hardest one. Now I'm gonna pull out my sticky note. What can I replace this whole numerator with, like the whole thing? 1. Sine squared plus cosine squared is 1. So we got 1 over sine, which is cosecant. Good job. That one was hard. We ended with the hardest one.